Alright guys, today is about right triangle trigonometry. You may remember this in the past as SOHCAHTOA, maybe from a geometry or algebra 2 class. The reason why it's called right triangle trigonometry, these rules will only work for a right triangle. So let's recap on what SOHCAHTOA stands for. SO stands for that sine of theta is equal to opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Okay, and this is all with respect to where the theta lies. So if it lies down here, then you go opposite, and so on. And then if it lies up here, you start opposite, going opposite of where that is. Okay. So what's new today is cosecant, secant, and cotangent, which we learned are the reciprocals of these three trig functions. We also started saying the word, the flip-flop. So in that case, cosecant is equal to hypotenuse over opposite. Secant of theta is equal to hypotenuse over adjacent. And cotangent is equal to adjacent over opposite. Okay? So now, if you look at these two triangles I have set up here, the only reason I drew two sets is so that you can see that opposite, adjacent, and hypotenuse are with respect to which corner of the right triangle you were talking about. Okay, it won't stay the same for every triangle. The only one that does is hypotenuse, and that's because hypotenuse is always across from the right angle. So for example, when I'm looking at this triangle that I placed the theta on the bottom, across from it, side B would be opposite. Okay? The one across, the side across from the right angle would be hypotenuse. And if you struggle remembering which is adjacent, list the other two first, and it'll be the last one left. But adjacent is the side that is always in between the angle that you're working with and the right angle. Okay? So, if sine is equal to opposite over hypotenuse, what letters would I place for sine on this one? B over A. Beautiful. If cosine is adjacent over hypotenuse, what letters would I place for cosine? C over A. If tangent is opposite over adjacent, what would I place? C over C. Okay? Now, if you already have the first three, it's easy to just flip-flop for the others. But remember, on a normal question, I won't ask you to list all six. I'll just ask you for one of them. Okay? So, for example, on a quiz or test, I could just say, all right, solve for the secant of this triangle. Okay? So now, cosecant is flip-flop of sine, so hypotenuse over opposite, which is A over B. Secant is flip-flop of cosine, which is hypotenuse over adjacent. So that would be A over C. And cotangent of theta is opposite of tangent, so adjacent over opposite. And that would be C over B. Any questions on that? All right, take a moment without looking up and try and do the right one on your own. Do remember that, again, we are working according to the top angle. I named it alpha just to have a different degree to be working with, different notation. But across from alpha will be your opposite. Across from 90 will be your hypotenuse. And in between the angle and the right is your adjacent. Again, take a moment and try and do those six. All right, so we're continuing on with this question. It says, find the value of the 6 trig functions of theta if b, one of the sides is 4, and c, the hypotenuse, is 2 square root of 5. So our final answer should end up being sine of theta equals, and the whole list. So we know that sine, and I'm going to keep writing this once you feel confident enough in the SOHCAHTOA. You don't have to keep writing this. I'll write it in the notes, but you don't have to do it like on a homework quiz or test. Sine is opposite over hypotenuse. So ka, so and then you flip them. Okay? And I am very visual, so I like to write these on my triangle. Okay? So if this is theta, then A is going to be my opposite. C is going to be my hypotenuse. And B is going to be my adjacent. So I already know 2 bits of the information. I'm missing the third. Okay? This is going to require you to go back into some old files that you've learned from math. If I have a right triangle and I have 2 sides given, how do I find the third? That's the degree. We're talking about the sides. Pythagorean, good. Which Pythagorean states that a squared plus b squared equals c squared, where c is specifically the hypotenuse. Okay? So I don't know a, I'm going to keep that as an a squared. B is 4, and c is 2 square root of 5 squared. Okay? So, if you guys haven't noticed already, I am obsessed with parentheses. They keep me from making mistakes. Okay? So, I'll show you how it could stump us on this one. Here, this squared belongs to the 2 and to the 5. So what is 2 squared? 4 times, what is square root of 5 squared? 5. So you have to multiply 4 times 5 there. Be careful, okay? Now, I have always told you that every square root has a plus or minus. The reason why we don't take that into account here is because I'm just talking about a distance along a side, okay? Yes. So if this is theta, opposite is literally the side opposite of it, across from it, okay? Hypotenuse is the one across the right angle. And then adjacent is the one in between the angle you're working with and the right angle. No, for alpha is the same. So the reason why I put alpha last time, I could put theta and put it up top, but just know that if I'm talking about the one up top, now this one down here is your opposite, and then the one in between the angle and the right, this one would have been adjacent. Okay, so it doesn't matter what it's called, it matters where it's located. All right, now that we know what what A is, now we can finish answering our question. Okay, so sine is opposite. What number am I picking? 2 over hypotenuse, which is 2 square root of 5. Talk to me about that. The 2's cancel. Be careful that square root of 5 is located in the denominator, so it has to stay located in the denominator. And then I put a 1 on top. Okay? Now remember last class we talked about rationalizing denominators, not leaving the radical down there. So what do I do to this fraction? Beautiful. Multiply top and bottom by radical 5. And I'm left with radical 5 over 5. Okay? Cosine is adjacent, which is 4, over hypotenuse, which is 2 radical 5. The 2 and the 4 reduce. So now I have 2 over radical 5. And I'll be doing the same exact rationalizing. I'm left with 2 radical 5 over 5. Tangent is opposite, which we see opposite over here is 2. Over adjacent, adjacent is 4. This is a nice one. 2 over 4 just reduces to half. Now I know we know that we could just flip-flop these three for our next answers, but again on the Quizzer test, I'm not going to ask you for 6. I could just ask you like for secant or cosecant. So I'm going to refer back to the triangle, okay? Cosecant would be hypotenuse, which is 2 radical 5 over opposite, which is 2. And this one cleans out really nice. The 2's reduced. And here the radical 5 is in the numerator, so now it's just square root of 5. Okay. Secant is hypotenuse, which is 2 radical 5 over adjacent, which is 4. The 2 and the 4 reduce. So I'm left with square root of 5 over 2. Radical 5 and square root of 5 mean the same thing. Okay? Synonyms. And cotangent is adjacent. Adjacent is 4 over opposite, which is 2. 4 over 2 just reduces to 2. All right, the next thing we're talking about is cofunction identities. So a cofunction identity, for example, if I'm working with cosine of some value on the unit circle, this formula will tell me where sine on the unit circle gives me the exact same quantity. So for these 6 formulas, notice that these 3, the trig functions just change locations for these 3, in case you're memorizing. And also, if we are working in radians like we will in these 2 examples, instead of using 90 degrees, we're going to use its equivalent in radians, which is pi over 2. Okay? So, cosine of 20 degrees, the one that starts off with cosine, I could say cosine of 20 equals sine of 90 degrees minus, and then I plug in the theta that they gave me, 20 degrees. What's 90 minus 20? Yep. So your answer is sine of 70. It's really easy when it's in degrees because our subtraction is really easy. So just to give you an idea on the calculator, so you can see how this works, I'm plugging in degrees, 20 and 70 degrees. So for that reason, my mode switches over to degrees. Okay? Now, if I put cosine of 20, I'll get that decimal. I should get the exact same answer when I put sine of 70. This is a good way for you to check when you're taking a homework quiz or test, and you see we get the exact same decimal. So again, cofunction just told me what other value on the unit circle will have the same exact answer. You didn't get that decimal? Are you still in radian mode? Yeah, if you're not in the right mode, it won't work. So rule of thumb, if I'm plugging in a degree, 20 degrees, 70 degrees, I have to be in degree mode. Anything else that does not have the degree symbol, you should be in radian mode. Okay? It doesn't have to have a pi in it. Cool? Now, because the majority of the time I work in radians, I'm going to take a moment and switch it back. So no, I know I don't mess up later, okay? All right. I just want, the cofunction value is with a trig function, okay? You can do the rest to check, but that's what I want. All right, so cotangent, I find cotangent right here. Cotangent of some value is equivalent to tangent of 90 minus the theta that they gave me, which is 40. Okay, 90 minus 40 is, yep, so my answer is tangent of 50. Again, you could always plug both of these into your calculator and they should give you the same exact value. Yeah, the question and then the answer. Okay. So now we go into radians. So instead of using 90 minus, I'm going to use pi over 2 minus, which will cause us to do a little bit of subtracting with fractions. Don't let it intimidate you though. So cosecant is right over here. It is secant of 90, or in this case, pi over 2 minus what they gave me, which is pi over 3. If I want common denominators, because I have to subtract those two, what would I multiply my first fraction by? Good, 3 over 3. And how about the second one? 2 over 2. So now I can say secant of 3 pi over 6 minus 2 pi over 6. And my answer will be, what's 3 pi minus 2 pi? Good, so just secant of pi over 6. So one little extra step there. Right, so if I wanted to check this one in my calculator, I'd put both of these in, but because I'm not putting a degree, I need to make sure I'm in radian mode. Okay? Absolutely. If you know the degrees from the unit circle of pi over 3 and pi over 6, then you could stay in degree mode. Okay? Somebody answer that. How do we get cosecant in the calculator? 1 over sine. Okay? So use your, okay, I'm going to set it down really quick. Use your alpha. No, that's something else. We'll talk about that today too, though. So press alpha y equals and n over d is for a fraction. And you press 1 over, cosecant is the inverse of sine, excuse me, the reciprocal. And then you put your pi over 3. So I could do another alpha y equals, and it'll put a fraction within a fraction, okay? Look how pretty that looks. And that'll be your answer, 1.15. Okay? You can do the same thing with secant is the reciprocal of cosine. And then you can see that they both gave me the same decimal to check. Okay? Any other questions with the calculator? All right, let's do this last one. Cotangent has a flip-flop of tangent. And instead of 90, I'm saying pi over 2 minus pi over 12. Notice in my work, the moment I see fractions with different decimals, I'm leaving a gap. I know I'm going to have to multiply to get common denominator. What do I have to multiply to the first one? All right, so what do I need to multiply by pi over 2 to get a common denominator? 6 over 6. Do I need to multiply the other one by anything? Nope. We're good. So tangent of 6 pi over 12 minus pi over 12. That gives me tangent of 5 pi over 12. Cool? We are done with cofunctions. All right, so now we're moving on to some SOHCAHTOA word problems. The first thing I want to go over with you is this wording that you might hear is angle of elevation or angle of depression, okay? So Angle of elevation is when you are looking up. Angle of depression is when you are looking down. So a lot of times people draw a building, and if you want to know the angle of elevation of the man to the sun, people think elevation means on top, so they usually think about this angle up here by the sun. But if we're talking about the angle of elevation, it's wherever you can stand and look up. Could you stand where the sun is and look up and see the man? You'd have to look down. So from the sun to the man would be an angle of depression. From the man to the sun would be an angle of elevation. Same thing from the man to the car. If I'm talking about this triangle down here, the man to the car is angle of depression because he has to look down to see the car. And the person in the car, this angle where he is the angle of elevation because he has to look up. Does that make sense? All right. Next thing you need to know is that whenever we're working with word problems, you must be on degree mode, okay? All of these measurements are usually done in degrees. So if we're looking at slide 10, they're talking about some ponds. So I drew a little blue kind of pond-like thing, and they want to know the distance across. SOHCAHTOA, believe it or not, is one of the most useful math equations that is used in real life, okay? So if we had some massive ponds, the workers who need to measure, let's say to build a bridge or whatever, are not going to send a guy in a boat with a measuring tape and go measuring all across the lake. They're going to find some measurement that they can find easily, and then use SOHCAHTOA to get the rest of it, okay? For example, if I want to know the distance from us to the moon, you know how you can look on Google and find the distance from Earth to the moon? Do you think somebody went with measuring tape from Earth to moon? No, they use SOHCAHTOA. You get a shorter distance, you find the angle from us to the moon, and then you can find that distance. Does that make sense? So SOHCAHTOA is huge in astronomy, in architecture. You want to know the height of a building, things like that, okay? All right, so let's start off. This question wants us to find the length across the pond. So this is what they're looking for, okay? If the degree that they gave us is 24, the question mark, is it opposite, adjacent, or hypotenuse? Opposite, right? Let me write that in red. This is opposite. And then they didn't give us this side, but they did give us this one down here. Is this side down here opposite, adjacent, or hypotenuse? Adjacent. So they gave us three things. They gave us theta. They gave us, we're looking for opposite, and they gave us adjacent. Which, out of SOHCAHTOA, works with opposite and adjacent? TOA, right, tangent. So TOA works with opposite and adjacent, so that is the one that we're going to want to pick to solve this problem. So TOA stands for tangent of theta equals opposite over adjacent, okay? Let's start filling in what this question has told us. Tangent of, who's my theta? 24. You see how it's in degrees and why I need to be in degree mode? Okay? Equals opposite. I don't know opposite, so I could put a variable. I could put an X. I could put an O for the word opposite. It's up to you. Over adjacent. And adjacent is 1200. Okay? My goal here is to solve for that X. What do I do to isolate the X? Beautiful. Multiply that 1200 over to the other side. So I have 1200 times tangent of 24 is going to equal X. At this point, you go straight to your calculator. Okay? Again, making sure I am in degree mode. And if you want a quick check on these TI-84 calculators, you see those words on the top row? The second to last word will tell you whether you're in radian or degrees. So right now it says radian, so I know that I need to go and switch it. Okay? Second mode will always take you back to your home screen. So now type in your 1200 times tangent of 24 degrees. And again, you can see up here that I'm in degree mode. And you press enter. The length across that lake is 534.274, and then our measurement was in yards. Okay? That's it. No, not tricking you. Told you today would be easy. All right? Yes, we're going to do a few more. All right, so let's look at these last two questions. In this first one, I tell you the building is 40 feet high. Okay? And then the shadow is 36 feet long. Find the angle of elevation. Am I talking about this one up here or this one down here? The one on the bottom. Okay? So 40 across from the theta is your opposite. And then the one marked with the right angle and in between the other angle is your adjacent. Okay? So working with opposite and adjacent, again, we have tangent of theta equals opposite over adjacent. Okay? So now we fill in what we know. What we're missing this time is theta. Let's see, we do have opposite, which is 40, and adjacent, which is 36. Okay? This is something new. You've never seen this before, okay? If you want to isolate theta, remember back in algebra when you wanted to isolate like a variable, you would do the inverse operation, okay? So there's this thing called inverse tangent. You've never learned it before, okay? And the way I move the tangent over is by doing inverse tangent. It's tangent with a little -1, and you apply it to the other side. The way we do that on our calculators, you see how on top of tangent there's a tangent with a little -1? Okay? So in order to press that, you have to press the second button. So you're going to press second tangent, and it'll put the tangent with a little -1. And then you are going to put 40 over 36. Again, making sure you're on degree mode, and the angle is 48 degrees. Okay? And you are done with this one. All right, so this last question, they tell us that the tree is 40 feet tall. Okay? They want to know the distance from the tree, and they tell me that the angle is 32 degrees. So across from the angle, I have opposite, which is the tree, and what I'm looking for is adjacent. All right? So again, opposite and adjacent is tangent of theta equals opposite over adjacent. Fill it in. Tangent of 32 degrees is opposite, which is 40. And now adjacent is the one I don't know. So now I see the x in the denominator. This is a third scenario. Okay? Now, you kind of have two methods. You could either multiply the x to the other side and then divide the tangent over. Or if you're more comfortable with cross multiplication, that's another method you can use. Okay? So for now, I'm going to do the first one. I'm going to multiply the x over and say x times tangent of 32 equals 40. Okay, I'm going to come up here. And then to isolate the x, I'm going to divide the tangent of 32 degrees and say x equals 40 divided by tangent of 32 degrees. Okay? Plug that in your calculator. I use alpha y equals to make the fraction. 40 over tangent of 32 degrees. Press enter and you have x, the distance to the tree, is 64 feet, right, 64.013 feet. And those are your three scenarios of SOHCAHTOA word problems.